So our focus today is we're identifying types of graphs. So we have 3 graph types that we've talked about this year altogether. We'll go through them one by one. Linear functions is what it was, chapter 3, I think, what was kind of at the beginning of the year. Where a linear function means we're talking about this in the context of that it is it's a line. Linear meaning line. Where m is like our slope, b is our y-intercept. And what makes this a linear line, kind of a big characteristic that we're going to look for today as we practice, is what we called a constant rate of change. So constant rate of changes mean it's going like up and over the same amount each time. So for example, we could have like a constant rate of change of 2, meaning that our outputs or our y values are going plus 2 each time. So plus 2, plus 2, plus 2. That's what a line is. And constant rate of change, it's always like you're adding the same amount each time. Exponential functions is it kind of looks like this swoop up, where it starts off kind of a slow incline and then it inclines very quickly. That is the graph of our exponential. What makes an exponential, what it gives it this shape, is that it has this x term on the top. If x is an exponent, or x is the exponent, that means it's an exponential. This, instead of looking for a constant rate of change, what we look for is a constant ratio. That means your outputs are being multiplied by the same amount each time. So I go from like 2 to 4 to 8 to 16 to 32. Each time my outputs are being multiplied by 2. So that's what we'll call a constant ratio. We can do the same thing if we're dividing. Say we're going 10, 5, 2.5, 1.25. That means we have a constant ratio of 1/2. And our most recent graph is our quadratic. It has the shape, we give the shape a name, it's a parabola or a parabola. And kind of the key characteristic about a parabola is that it's symmetrical. Meaning that points are going to be mirrored on either side of it. So this point and this point are going to have the same y coordinates, but not the same x coordinates. So what we'll do today is with points and tables, and then on your homework you'll have a few graphs too. You'll say whether it's linear, quadratic, or exponential. So looking at example 1, we're given points. You always want to look at your y values. So your y values are what comes second. All right. So your y values are what are highlighted. It's -6, -9. This needs to be a -10, so you got to make one edit. This should be a -10 in the middle here. -10, -9, -6. So, taking these values, we have to look and see what we have. I would say first, test if it's linear. To see if it's linear, these values should be going up by the same amount each time. To go from -6 to -9, we would add 3. But to go from -9 to -10, we're taking away 1. To go from here to here, we would add 1. This is we take away 3. So it's not the same, but if you were to write that out, kind of starting in the opposite direction, you'll see that it's mirrored. So to go this way and this way, we would have to take, we'd go +1, +1. Go from this way to this way. This would be a +3 and a +3. So if you think of this middle point as your like line of symmetry, it's symmetrical on either side. This would be a point down here at the bottom. We would go to the side and we go up. So this would be an example of a quadratic. So in a quadratic, what you're looking for is a point that you can mirror on either side. Here, this would be our vertex. And these points would be mirrored on either side. Another easy way to do all of these problems is you could also just make a little sketch of a graph. So we made a little sketch. If we plotted our vertex, -110 would be all the way down here. If we plotted it 0, -9, that would be right here. 1, -6 is about here. And then it would be mirrored on the other side as well. So this does make, in fact, make that parabola shape. All right. We'll talk through our example B now. Our coordinates are -9, -7, -5, -3, and -1. Our pattern here, if we look at the numbers that are highlighted, to go from here to here, we have to add 2. Here to here is an addition of 2. Add 2. We add 2 as well. So since this has a constant rate of change, we're adding 2 each time, or +2. This would be a linear function. Yes. To have a what? A. Oh, sorry, I didn't even write A. A is a quadratic. I drew a picture of it, but I didn't write it. All right, so for example C now, we look at our y values, and we don't have a constant rate of change when we add, because here we would have to add, so we would add 0.25, here we would add 4.5, here we're taking away 2, here we're adding 2, so we don't have a constant pattern that's linear. We don't have anything that's exponential either, because when we divide, we're not multiplying by the same amount each time. It's not increasing quickly, or it's not decreasing quickly. So this would be, it's not linear, it's not exponential, and it's not quadratic. So this would just be a bunch of points. It doesn't have a name to it. So we'd say none. Right. All right. Last examples we're due is now if we're given a table instead of points. Are you guys done? Is everybody like done? You guys are kind of acting a little skittish. So when we're given a table, tables are just another way to express points. We could have the point -2, comma, -1, -1, comma, -2, 0, comma, -1. Where here and here we have points mirrored around our vertex. We do the same thing. If you didn't see that mirroring, you could draw a graph of this, and you could see that it makes our U parabola shape. So it's a quadratic. Quadratic because I see that I have kind of a middle point here, and at least one pair, I have at least one y value that's the same, that's mirrored. To go from here, I'm adding one and adding one if I go from either side of my vertex. On example B, I'm going down 3 each time, so this would be linear. Finally, C, we're going to make our own version of C. So make a table, X and Y table. We'll go from -2, -1, 0, 1, 2. Let's say we had something like it's 4, 8, 16, 32, 64. This where each time we go, we're multiplying by 2. Multiplying by 2. Multiplying by 2. So this is an exponential. If, say, we were decreasing, you want to make kind of a separate, I don't even have to make a table. If you were saying your points were let's say 12, 6, 3, 1.5, 0.75. This would be an exponential still, but your ratio, you're multiplying by half each time, or you're dividing by 2. Both of those are the same thing. Exponential. Linear. Yep. Two or more y's that are the same, then would be a quadratic. Yep, that's a good way to put it.